So, Julie, what did you say for what is a relationship? What two things have in common? Okay. I guess that could be. So could you give me an example? A ratio. Okay, yeah, that's an example. Like if we have a student-to-teacher ratio of 15 to 1. That's a relationship. It's how many students there are per teachers. I like it. So we'll give an example. Skylar, you had your hand up? Concepts that are connected? Okay, I like that word connection. And I'll just generalize it to things that are connected in some way. So you could have two people that are in a relationship. If somebody asks you to give emergency contact information, they often ask, what is that person's relationship to you? Father, mother, whatever. Okay? Good. But we need multiple things, right? You can't have a relationship with just one thing. Right? Is that a question?
No.
Response, yes.
Yeah. I have like an example, like two lines that are parallel or perpendicular,
Mm-hmm.
or like two numbers that are inverse to
Okay, so again, two things at least. Good. So that's the key here. We're talking about multiple things and their connection in some way. It doesn't necessarily mean that there's a cause and effect relationship. Not necessarily a causal. A lot of people will see that word and say, that's not how you spell casual. I'm not trying to say casual. It's causal, of relating to cause. It is a word. Mm-hmm. Not necessarily a causal. Relationship. Just means there's an association. Like if we know one thing, we know the other. All right, any other questions, comments on one? Okay, another random person. Jackie. Can you give an example of a mathematical relationship?
Like what Jordan said.
Okay, can you repeat that? What Jordan said?
Like if two lines are parallel,
Okay, so how lines relate in terms of do they intersect? That's an example. Could I get a volunteer for another mathematical relationship? There are tons. James?
Congruent angles.
Congruent angles. Sure. And for example, those things happen when a line crosses two parallel lines. You'll get congruent angles. You'll get other angle relationships, but that's one. E equals mc squared. It's a relationship. What's E? Energy, M. Mass, C. Speed of light. So if you know mass, you know how much energy is contained. If you know how much energy there is, you know how much mass there will be. Because C is a constant. Another one from physics. F equals ma. What's F? Force. M, mass, A, acceleration, etc. So there's many instances in math and in science. Math is the language of science, in which we have relationships. Something that relates two or more things. Good. I think we've covered that sufficiently. Number 3, what are two ways to express a bivariate mathematical relationship? Prefix bi means what? Two. Variate relates to? Variables. Okay, so two variables. Let's start with one way. I'll go to volunteers for this one. What's one way that you know of to express a bivariate mathematical relationship? Jordan.
I don't know if this is right, but like a linear equation.
Okay.
So
A,
like
li-
a line.
a linear equation. So I like how you use the word equation there. That's one way. Okay, you could refer to it as a formula as well. E equals mc squared, for example. So equations are shortcuts. This is a way to concisely express a relationship. What's a non-concise way? What's that? Expression? These are examples of expressions. It's a non-concise way to express a relationship. Think about when you were learning how to graph points.
Inequality.
Before that, how do we express points? Coordinates, ordered pairs. So that's another way to express a mathematical relationship. It's not a concise way, especially if you have a lot of points.
What's concisely?
Short. A set of ordered pairs. Like, for example, 2 comma 3, 6 comma negative 1, 0, 9. Next, what is a function? Jordan.
Oh, it's kind of like when you plug something in for x.
Okay.
So like, it's an equation where you can plug in a number and get the y and get like the x and the y.
Yes, that's an example of a function. I'll go to volunteers. Brooke.
A relationship or expression involving one or more variables.
Okay. There is a certain condition, though. So that's a great starting point. Yeah.
Is it where we can have more than one x, where you can have many y values?
It's a relationship in which each x value only corresponds to one y value. Okay? So it's a relationship. What were you saying?
You can't have two x values.
If you see repeated x values, it's not a function. A relation in which each x value or input corresponds to only one output. So it's a relation that has a certain condition. Now, before I show you my engineering textbooks, which have hundreds of functions within them, can you give me a real-world example?
Well, now, so
Tell me again.
when you plug in the x values on a line with y values.
Okay, so a linear equation for example, f of x equals 2x plus 1. You plug in the value of x, you get the value of y. Is everything okay?
Yeah.
Okay. Any other? Skylar. Location as a function of time. Sure, that's a physics example. When you say that something is a function of something else, it means that it depends on that other thing. Let's just do a hypothetical. Your grade is a function of what? Shout it out.
Your test,
Test scores, homework, participation, effort, etc. Okay, so you already have an idea of what a function is. It's just that we're adding this special mathematical condition that says that it only produces one thing for each input. If it produces more than one thing, then it's not a function. That's all. It would be like if you asked the weather model to tell you what the chance of rain was today. If it gave you more than one chance of rain, that would be confusing, right? That's not a function if it gives you more than one chance. Okay? Hi. Now, I can show you, I'll just pick one of these. Microwave engineering. It's not just the engineering of making microwave ovens. It's more general than that. And shouldn't take me long. Here we go. Third page that I went to. Here, this is function notation. I don't even know what e sub z is, but I know that e sub z is a function of, these are Greek letters. The first letter is Greek R, rho. The second letter is, in Greek you actually have a letter for the ph sound, like phone. It's one letter. Is that a question?
Yeah.
Yes.
So, like, this one's function.
This is an example of function notation. Here, anytime you see a letter, when we introduce functions to you, it's often f. But as you can see, it doesn't have to be f. And then you'll see open parentheses, and then the things on the inside are the independent variables. It's what this function depends on. So whatever e of z or e sub z is, I know it depends on rho and phi. Sometimes people call it phi. Good. So that I wanted you to see, some reason for learning this particular stuff. It's necessary to do the stuff that follows. Okay. What are two ways to check if something is a function? Surely you told us one of them. Could you repeat it for us?
Mapping.
Mapping? Okay.
And vertical line test.
Good. So, let me use an example from the book. This is a mathematical relation. It's very simple. 1 is associated with 2. Negative 2 is associated with 4, etc. What we want to know is this a function? So here's one way to do it. So I'll put in 1, and that goes to 2. I put in negative 2, that goes to 4. I put in 3, that goes to negative 1. Does each x value correspond to only one y value? Yeah, therefore is a function. Each x maps, just another word for connects, to only one y. Let's do another one. Negative 4 maps to 1. Negative 2 maps to 1. But that's not a problem. The problem comes when you factor in this last ordered pair. So not only does negative 2 produce a 1, so to speak, it also produces 0. So this is not a function, since negative 2 maps to more than 1. And I think we care because, like I said before, we like it when our formulas produce just one thing for each given input. If they produce more than one thing, it leads to confusion. Like if I stick a negative 2 in, I get 1 and 0 out. Well, like, what do I do? Okay? Good. And then Shirley also mentioned the vertical line test. Yes. Shirley, can you tell us about that?
Basically, the vertical line test is checking the values for y. So you
Okay.
can have, so when you have a function, let's say a linear equation, normally there is no overlap. There's one point each time you pass through an x value, it doesn't have more than one y value.
Exactly. So I'll paraphrase what she said. The vertical line test is used to determine if something is a function. So if you had a linear function, for example, this one, no matter what x value you choose, a vertical line will only cross it one time. Therefore, that's what the 3 dots mean. Therefore, it is a function. You can do the same thing with points. Okay? Any questions on either of those?
So we made that U-shaped thing, it's not a function?
A U-shaped thing. It depends on how the U is oriented. If it was sideways, absolutely. So, one of the questions here is give 2 examples of relations that are not functions. Ashley gave us one of them.
What is it called?
Could be a sideways parabola, what you're referring to. Okay, so if you had a sideways parabola, you could draw a vertical line that crossed through more than once. So this is not a function. And I'll go to volunteer to get another example of a relation that's not Jackie.
Something like x equals y squared.
X equals y squared. Correct. That's an example, well, that's an equation for a sideways parabola. If you're not understanding why this is not a function, well, you could graph it. But also what you can do is you can solve it for y. How could you solve this one for y, Jackie? Square root. Plus or minus. So then you're left with y equals plus or minus the square root of x. And you can graph each of those. And when you graph the positive root of x, it looks like this. And when you graph the negative root of x, it looks like this. So you'll get the sideways parabola. Good. Any questions on 7? Number 8. Domain. Yes?
There's 5 in it.
Thank you. Anyone remember what domain is? Jackie?
The domain is the first chord. It's like the set of the first chord and it's from the order there.
Good.
I don't know what that means.
Okay.
Is that the x value?
Yep. All the x values. The domain is the set of all the x values.
Aren't they all different?
They could be.
What would be the domain? Like every x value? Right, everyone.
You have to give me an example. So, for example, if you had y equals the square root of x, you can't take the square root of what, Jackie?
Of x, of y.
Give me something in terms of numbers. Because x and y just stand for anything, generally.
Like 2.
You can take the square root of 2.
0.
You can take the square root of 0.
Um,
Negatives.
uh,
Okay.
If
So,
it was a pair, though.
a pair?
If it was like -2 and -3. So would it be like -2 is the domain?
Yes. Yeah. So the domain of this is 0 to infinity. And that's in interval notation. That's why we had you learn that, so you could express domain and range in a shorthand way. And then if you had a set of ordered pairs, like 2, 3, 6, -1, 0, 9, then, Jackie, what would the domain be?
2, 6, 0.
Yep.
So you could give us all those points. Like, what if you just give us 1 point?
Then there's just one element in the domain. Okay? So it's just the set of the x values. Guess what the range is?
Set of all the y values.
Wow! Genius. Domain is x, range is y. Okay. I'll be really impressed can somebody give me the range of y equals square root of x?
Three.
3? There's more to it than that.
Negative one.
-1 is not part of the range.
Like 3.
3 is part of the range, but there's a lot more to it than that.
2.
9 is part of the range. 2 is part of the range.
4.
Yeah, but instead of us just shouting out a bunch of numbers, we'll all die before we're done because the range is infinite.
Four.
But it's not completely
0
infinite.
to infinity.
Very good. The range is also 0 to infinity. Good luck getting a negative out of a square root. Okay? And then I'll be less impressed, but still pleased. The range of that ordered pair, set of ordered pairs. Go ahead.
Like
3, -1, and 9. Or you can put it in order. Okay?